The solution approach is to add specific interfaces for the Mark IV that inherit from or implement our abstract classes. We can also factor out the specific communication mechanisms by which the sensors are accessed. Have a look at Martin's specific Java implementation, which is provided on the class resources page.
So for the part about we could either inherit or implement these abstract classes for our design, would I guess a situation for inheriting the abstract classes, if we want to define some more policies about maybe a particular class of coffee makers, like if we have, for instance, our containment vessel, and it has these abstract things that the containment vessel, the concrete classes would need to provide, and then we have maybe a slew of coffee makers that have this style of containment vessel that's a little bit more particular, but still we want to have another kind of inherited abstract class and not like an implemented concrete class.
So let me comment a little bit and then see if we can refine the question here a little bit.
Okay.
So different object-oriented languages provide different capabilities for doing refinement. Okay. Java has both interfaces and subclasses, but it only has single inheritance. Mm-hmm. Okay. C++ has multiple inheritance, but it doesn't have interfaces, although they both have abstract classes. So when I said about inherit or implement, I was really being generic across the programming languages. Okay. But in general, implementation of abstract interfaces is nice because in the abstract interface, you've captured something that is purely abstract. In an abstract class, you can also have concrete methods. Okay, so if it's purely abstract, you've really captured the essence of something. So, we could even imagine a situation where each of the roles that is expressed by a class is defined in a separate interface. So we might have a relatively vanilla class that implements 3 roles, okay, and just provides the details of doing that. And then if we wanted to change one of the roles or one of the use cases, we just can go and look at that one particular interface. So given that, you want to re-ask your question?
I think that covers kind of my question. I guess I have a better understanding, I think, now. I guess the takeaway seems to be that with a very abstractly defined system like this, it's kind of like saying, well, I don't care how you provide the isReady function for the containment vessel. As long as whatever you implement provides it, it's going to fit with this abstract definition of how our system works. So you should be able to extend and have some kind of wild and crazy thing that does isReady, or maybe your more typical Mark IV design of how the containment vessel becomes isReady.
So one way of thinking about this is you're really, at this stage, designing policy. Mm-hmm. And that policy can take the form of protocols, that is, the names of the abstract methods that have to be called. Okay? And the attitude here is to be as abstract as possible, or at least the more abstract you are, the more flexible you are with changes in the future. Of course, you can go overboard if you're only ever going to have one version of this thing. You might not want to spend a lot of time abstracting on it, and maybe there's a sweet spot in between. But in general, and reflecting back on some of what we've talked about earlier with respect to maintainability of the modules and so on, you want to provide as much abstractness as you can in support of eventual reuse.